So we had a problem before we started recording. We were getting some weird importing errors. So I copied the whole controller and auth file from the project that I already set up before. And we're going to try to go as far as we can with this. Then I think at a certain point, I'm going to stop and I'm going to switch to the full project to show the different changes in the front end. But we're going to go through the main or the big bulk of the code, which is in the controller we're going to look at now, and in the login form in the front end, and a little bit of work in the front end as well. But the main bulk we're going to go through now, and then we're going to switch to the full project. Majid had a question before we started this recording about the theoretical things about salt and encryption. And there are no one standard to do everything. So if you used a library online, you're not going to have to face any of these things. You're not going to have to hash the password yourself, or you're not going to create the tokens yourself. So now we're going everything manual. We're using the libraries ourselves, and we have an expression for that we're rolling up our sleeves and actually digging up and doing the work ourselves. And this is good to understand everything from beneath, like the covers, what libraries do internally. But password hashing is a way to convert a password to a format like this. And it got generated actually in the code somewhere, so the code ran again. So password, so the password was not defined, then it console logged it here somewhere. Yep, here it is, and you can see that hash with the value, and this is coming from this line. So this is the result of this. So it took Jacob, and we can check what salt is in a couple of seconds. So salt encryption, but you can still go further with that after the call as well. So salt is a random data that is used as an additional input to a one-way function that hashes data, a password or passphrase. It is used to safeguard password in storage. So usually if you want to save the password in a database, you would just create a table that has the ID and the username and the email and the password. And then we save the password as is. And then when the user logs in from the form, it's just going to be a normal form that you submit. And then you check the username and password are the same in the server, in the database, and then you return the OK. But you cannot do that. You cannot actually save the password in plain text, because that's not secure. So the way in Salt is it converts whatever you have in a different format that you cannot see the actual value. But if you have the original value, you can still use the same algorithm to compare the original one that was sent again from the client with the hashed value that you have in the database. And that's what libraries do. In the internals of it and how does it work, I actually don't know. We could read more about that, but I think it's a more secure way than MD5 hashing, which is a way again to convert strings to a format that an unreadable format. So there are other ways. MD5 encryption. So it's a one-way encryption that you can encrypt from one format to the other, but you cannot decrypt from the hashed value to the original. So now when I hash Jacob and it returns this weird format, I cannot actually decrypt. I cannot get this value and convert it back to Jacob. I can only, if I have Jacob again, I can convert it to another hash and make sure that the new hash matches the old hash. And that's how I can confirm that that it is the same password. But if I only have the hash, if the database got compromised or someone hacked my database and they got the password, they only get the hash, but they would not be able to know the original value. Sorry if I confused you, but it's a way of encryption. We can read more on that and we can discuss it after the call. But this was the just a couple of minutes on that. So we hash the passwords and we save them in a secure way. So if anyone got this, you will not be able to get Jacob. So now we're going to comment this. We don't need it anymore. This is the value we're going to use, and we're going to assume that we got these two values from the database. But we're just skipping this step for now. So we ran this function and we got the value from the console log. We don't need it anymore. So we're going to comment it out. And usually if you use any library, it's going to take care of that for you. So you're not going to need to do it manually. But if you ever need to, this is how you do it. So this is one concept. I copied the rest of the controller because I had a problem that I couldn't figure out. So we're going to go through them one by one. So the login function, the full version of the login function of this, which is a very simple one, it checks the login info. So in the login from the front end, we're going to send email and password in a post request. And here we get them in plain text. We could also encrypt it in the client, but we don't have to do this now. It's not that secure. So we get the username and password, and we check that they are correct. And the other function that does that is a function that takes username and password, and it checks that the user that was sent is the email that we have hard-coded here. And to compare the password, I don't have the plain password anymore here. I only have the hashed one. I use pcrypt to compare the password that was sent from the client with the hash directly. And I have to do it with this library. So it's going to take the thing that was sent from the client and compare it with the hash that we have. That's how we check that the user is actually logged in. And it's a Boolean, so it ANDs both of them. So the user and the password has to match. If this was a database, if we save the things in the database, we would compare, we would get the record where the email is equal to email, and then we would get the password and compare it with it. So we'll have a select query here somewhere before that and not have these hard-coded. Okay, so this checks the login info. It basically just compares the two values. And going back to the login, so if not, check login info, meaning that the login info is not correct, username and password are not correct, we're gonna return 401. So here the status code is something, I guess you guys know that, like 200 is a success, 400 is failure, I guess, or I'm not sure what was that. 401 is unauthorized, 404 is not found. So we're going to send 401, which says you are unauthorized. And we're going to send a JSON object with a message saying invalid credentials. We can improve that. We can send constant messages somewhere. There are a million ways to improve this, but this is the basic idea of it. So the login function is not going to work here. It's going to fail. But if it passed through here, because we have a return, so if it's not correct, it's just going to stop here. Otherwise, it's going to continue, and it's going to create a token for them. And let's go to the create token function. We're going to again send the email and password. And the create token function is just right below the check login info. So create token uses JWT, and we mentioned it in the beginning of the call. So JWT is short for JSON Web Token, and it will take a JSON object and we'll take a password, and a password is just a string that we have, and this is a secure password. It cannot be shared with anyone. So I just created a random password somewhere, and it's gonna convert this JSON object to, again, a weird looking string, an encrypted string. But this encrypted string will be different than the salt because we will be able to decrypt it, meaning convert it from this weird looking format to the original format if we have the password. So only our server can do that because only our server has this password. So we're gonna sign the user info in a token that only us can know the full contents of it. Everyone can read what we're going to send here, which is the username and email, but it's going to be signed by us. Signed meaning that we're going to have a signature in this message that only us can decrypt. And that's how the server can know that this message is only sent by him, or this token is only generated by this server. So the JWT password is just a password, a different one that you have hard-coded in the app. And we create something with the email. You could have the profile name. You could have any public information that you want to send back to the client, the roles, anything you want to save in you want to save and share with the client. For now, we just want to have the email. So we send the user called email. It's bad namings, but now we have an object with the email in it, and we're gonna convert it using JWT, and the function is called JWT.sign. We can again talk about that if you're confused about anything. We are introducing a lot of things. So this is different from bcrypt. Bcrypt hashes passwords. It's a one-way encryption. JWT is a way for us to create a token that we can send to the client, and then the client sends back to us, and then we'll be able to decrypt it and make sure that it was us that actually created this token, meaning this user actually logged in. So we're going to create a token for this user, and this is the function. It is nothing that intelligent. Actually, we don't need the password here, so that was not correct from my side. We can remove that. So we only need this or any other information that we want. In a big application, you would get the user profile, meaning the full name, or any information that would the profile picture, anything that you need to wrap in a user info, maybe send it here or not. It depends on the application. So create token text email generates a token, and it's a long string. Nothing crazy. We go down and we return this token in a variable, and we send it to the client. So this is the whole login thing. So the login form now is going to call this endpoint under /API/auth/login,